hello. Good morning everyone. So today we'll be discussing the continuation to the last class, that is mole concept, where we have discussed about the number of moles from its given substance for the given amount of substance. For example, they will give you something like 6 grams of carbon and they will ask you to count number of carbon atoms are present in that 6 grams of carbon. So how can we do all these things here? So calculating like counting the number of carbon atoms, it's highly difficult and we cannot do with normally. Okay, so for this kind of things we have something called mole concept. So what is the use of mole concept? We can relate number of moles. It means we can relate the amount of substance. For example, 5 grams and a substance ichar ankondi. So ఈ 5 grams of substance లో ఎన్ని particles, ఎన్ని molecules ఉన్నవి అని count చేయొచ్చు. Okay, using the number of mole concept. Or for example, one mole of a substance, 1 mole of a gas ichar ankondi. So at particular temperature, how much volume it will be occupying. ఓకే ఆ పర్టికులర్ సబ్స్టాన్స్ ఎంత వాల్యూమ్ని ఆక్యుపై చేస్తుంది అనేది ఇలాంటి క్యాలిక్యులేషన్స్ అన్నీ కూడా మోల్ కాన్సెప్ట్ ద్వారా మనం చేయొచ్చు. ఓకే, సో ఇన్ ఆర్డర్ టు అండర్స్టాండ్ కెమిస్ట్రీ అండ్ ద న్యూమరికల్స్ ఇన్వాల్వ్డ్ ఇన్ కెమిస్ట్రీ, మోల్ కాన్సెప్ట్ ఈస్ వన్ ఆఫ్ ది బేసిక్ అండ్ మోస్ట్ ఇంపార్టెంట్ topic and the chapter I can say. Okay, so without knowing mole concept you cannot do anything related to physical chemistry as well as other parts of chemistry and physics as well as other biology parts also. Okay, so this wherever chemistry involvement is there the mole concept will be useful. Okay, so again try to listen to this session very carefully. I will give you from very basic. Already I have discussed in the previous session on mole concept. Again I am giving it from very basic to the level that you require to get clarity in your class 11th and 12th. Okay, right, just follow me whatever I am explaining. Okay, then the next here will be seeing something like this. Okay, again I am showing the same content that I have given you the previous session. See, just read that lines which I have mentioned on the board. Yeah, let's go through each of these again. So when you hear a word mole, do not get confused or do not get scared. Mole is nothing but a term that we use similar to dozen. So when you go to a market and ask you dozen apples, the shopkeeper will give you 12 apples, right? Now in the same way in chemistry we will be using a term called mole. Okay, so mole is a term to indicate this many number of particles, 6.022 into 10 power 23 particles. Anything you can take. For example, if I say 1 mole of carbon atoms, 1 mole of carbon atoms, it means what it is indicating? 1 mole, it means this many number, 6.022 into 10 power 23 carbon atoms. So what do we mean by 1 mole of carbon atom? 6.022 into 10 power 23 carbon atoms. Or simply I can say 1 mole of electron. So 1 mole of electrons means this much number of electrons. Okay, remember. Now if you take 1 mole of carbon atoms and if you measure their weight, what I am saying, if you take 1 mole of carbon atoms, it means this many carbon particles, carbon atoms if you take, and if you measure the weight of that substances, that atoms, carbon atoms, you are going to get some weight. That weight is called its molar mass. So what do we mean by molar mass? Mass of 1 mole of a substance is called its molar mass. So molar mass is another term I am saying here. So one is number of moles, the number of moles, like 1 mole if I say, it contains Avogadro number of atoms or the species. Okay, the mass of 1 mole of a substance is called its molar mass. So for mass the units will be grams. Now see, in chemistry whenever I use the word mass or weight, both of them are same here. Okay, right. Now what is the unit for molar mass or molar weight? So gram per mole. Weight of 1 mole of substance na gram per mole is the unit for molar mass. Okay, now here how can we relate number of moles to weight of a substance? For example, I am giving you 6 grams of carbon atoms. How many grams of carbon atoms I am giving you? 6 grams of carbon atoms. Okay, now how many number of moles it will be, how many moles it will be? So number of moles will be equals to given weight of the substance by its molar mass, by its molar mass. What is the given weight in the question? 6 grams. Now you take that in the numerator as 6 grams. What is the molar mass of carbon? See, carbon having atomic number 6 now, so it contains 6 protons plus 6 neutrons. How many protons and how many neutrons? 6 protons and 6 neutrons and 6 electrons also. But mass of electrons is very less compared with the mass of protons and neutrons. Therefore, whenever we are calculating the mass of an atom, just consider number of protons plus neutrons. Add them, so this will be 12 units right now. So 12 units you will get. Even the molar mass also 12 grams. How much molar mass for carbon? It is 12 gram per mole. Okay, so gram cancel, this is 1 by 2. So simply you will get half mole. How many moles it is? 6 grams if I indicates it as a 6 grams if I give you, it means this is a half mole of carbon atoms, half mole of carbon atoms. Okay, remember this is an experimentally found value that whenever you take 1 mole of any substance, 1 mole of any substance, for example here if I say 1 mole of carbon atoms, it contains Avogadro number of particles. How many carbon atoms? Na means Avogadro number. Okay, so this Avogadro number exact value is something like this, 6.022 into 10 power 23 carbon atoms are present. Okay, ఎవరైనా 1 mole of a carbon atom అంటే ఎన్ని particles ఉంటాయి, ఎన్ని carbon atoms ఉంటాయి అందులో? Avogadro number of carbon atoms ఉంటాయని చెప్పాలి. ఓకే, సో ఇప్పుడు ఈ క్వశ్చన్ ద్వారా సి 6 grams అన్నప్పుడు 6 grams of carbon అన్నప్పుడు how many moles it become? Half mole na. So half mole means half of this number. So 6 grams లో ఎన్ని carbon atoms ఉంటవి? Okay, see 1 mole అవుతేనేమో, see if it is 1 mole we have Avogadro number of particles. Our answer is half mole only now. So half mole means what? Half of that Avogadro number. Half of that Avogadro number of particles will be there. Okay, like this you need to calculate. Okay, atoms. So 6 by 2, 3.011. So 3.011 into 10 power 23 carbon atoms will be there in the given substance. Okay, now let us move forward with a few more questions and proper understanding again with more clarity. See, whenever they give number of moles, what I am saying, whenever they give number of moles, so take it as given weight of substance by molar mass of the substance. Okay, this is the first formula to calculate number of moles or the amount of substance. Okay, for example here I am saying 5 moles of carbon atoms. How many moles of carbon atoms I have given? 5 moles of carbon atoms are given. Then what is its weight? Then what is the weight of the substance? What is the weight of carbon atoms? What is the total weight of this carbon atoms? So what you are going to do? Number of moles is given now. Number of moles is given and they are asking about weight. So now weight of the substance, weight of the carbon atoms will be taken as number of moles into molar mass of that carbon atoms. Okay, so number of moles are how many? Given in the question as 5. So take here 5, and what is the molar mass of carbon? So molar mass of carbon is 12 grams right now. So 12. So 12 5 is a 60. Okay, so 60 grams is the weight of 5 mole of carbon atoms. So what is the weight of 5 moles of carbon atoms? 60 grams. I hope it is clear. Let us move forward with little more next level questions, little more. Okay, I am giving you now, I am giving you like 32 grams of methane. What I am giving you? 32 grams of methane. Then calculate number of moles of methane, number of moles of methane. This is the first question. Methane means what is the formula? CH4. Number of moles of methane. And the next question is, this is the first question, and the next question, number of methane molecules, and also calculate number of methane molecules in this 32 grams of methane. And the next calculate, this is important, number of moles of hydrogen atoms in given substance. Okay, so try to write the question as it is, whatever I am explaining. Okay, so this is very important model. Okay, and the next one here, fourth question, number of hydrogen atoms in given substance. So it is very simple. First of all, read the first question, what they have mentioned. Given 32 grams is given and they are asking calculate number of moles of methane. Okay, so what we are going to do here, calculate number of moles of methane now. So number of moles of methane means number of moles I am indicating with symbol N. Okay, so N is the standard way to represent number of moles. So number of moles of methane is equals to given weight of methane. What is the weight of methane given? You take in the numerator. And what is the molar mass of methane? What is the molar mass of this methane? So take number of like given weight of methane is how much? 32. Okay, right now. And what is the molar mass of methane? See, methane means CH4. Right now, so carbon atomic number is 6, mass is 12. So it is 12 plus 4 hydrogens are there, each hydrogen mass is 1. So this is 16 gram per mole. So what is the molar mass of methane? That is 16 gram per mole, Whereas the given weight of the substance is 32 grams. Okay, you take it like this. So gram cancel, 16 2s are 32. So mole I can write in the numerator as 2 mole. Okay, right. So how many moles of methane we got? 2 moles of methane we got. So for the first question, number of moles of methane is how many? 2 moles. This is fine. It is perfectly correct. Then next, what they are asking, number of methane molecules. Okay. So number of methane molecules means, if I say in the 34 grams, here 32 grams of methane I am giving now. So I am asking how many methane molecules are there in the given bowl in this 32 grams. How can you calculate? First find number of moles. After finding number of moles, then do it like this. So number of molecules, which molecules they are asking? Methane molecules is equals to number of moles into Avogadro number. Why we are multiplying this like this? So if in 1 mole of any substance we have Avogadro number of particles now, like that, how many moles we got? 2 moles we got. So 2 into what is Avogadro number we have? 6.022 into 10 power 23. Okay, that's it. Just simplify this. So it will be 12.044 into 10 power 23 methane molecules are there. How many molecules? 12.044 into 10 power 23 methane molecules are there in the given substance. Okay, in the given 32 grams. Okay, right. Up to here, if it is clear, let us also do this for the next remaining 2 questions. See, what is the next question they have mentioned? Third one. In the law, చూడండి, number of moles of hydrogen atoms in given substance. ఈ ఇచ్చిన substance లో ఎన్ని hydrogen atoms ఉన్నాయి, ఎన్ని moles of hydrogen atoms ఉన్నాయి. So number of moles of hydrogen atoms they are asking now, hydrogen atoms in methane they are asking. So it is very simple ma. See, in one methane molecule if you consider, okay, methane lo any hydrogens you are having, okay, methane lo, in one methane there are 4 hydrogens right now. So that 4 number is called atomicity of hydrogen. What is that 4 called? Atomicity. So in one molecule of methane we have 4 hydrogen. Similarly, in 1 mole of methane we will be having 4 moles of hydrogens. Once again, in 1 molecule of methane we have 4 hydrogens. Similarly, in 1 mole of methane we have 4 moles of hydrogens. So that is nothing but atomicity, number of atoms if they ask. Every time whenever they are asking number of atoms, okay, particular atoms, atomicity of that atom into number of moles. Okay, so what is the atomicity of that atom? Which atom? Hydrogen atom. So it is 4 into what is the number of moles we got for methane? We got it as 2 moles. So it is multiplied with 2. So 8 moles of hydrogen atoms are there. How many moles of hydrogen atoms are there? 8 moles of hydrogen atoms are there. moles of hydrogen atoms are there. Okay, yeah guys, if this is clear, please hit on the like button, click on the like button, so that I can consider you are following the session. Yeah, the next one here, number of hydrogen atoms they are asking. So this is third. Next, fourth one, here I am asking you number of hydrogen atoms. Number of hydrogen atoms. So if this number of hydrogen atoms is equals to, what you need to take is number of moles into Avogadro number. So number of moles in, how many moles we got here? 8 moles now. So 8 into 8 moles of hydrogen atoms we got, 8 into Avogadro number, that is 6.022 into 10 power 23. Okay, that's it. So you can simplify this 16 17 1.48. Okay, so that's it. This is your final answer for the all 4 questions. Okay, right. Hope everything is clear. So try to write these discussion or just take a screenshot of it. If once again go through it, because you need to know these model questions first of all. These are very basic and important. Even I can show you the same model questions asked in NEET, JEE and ETSE. Okay, so just take these notes once again, clearly go through the question, same question. Okay, now I will be modifying it with some other terms so that you can practice. Okay, done up to here. There are 2 questions I am going to give you now based on the same discussion. You just solve it and tell me in the comment box. The first question here is very simple. Homework questions. These you need to do on your own based on our discussion. Okay, first one here. So I am giving you 88 grams of CO2. How many grams of CO2 I am giving you? 88 grams of CO2. Then calculate number of moles of CO2. First calculate number of moles of CO2, and second thing is number of moles of oxygen atoms, and the third thing is number of oxygen atoms present. Okay, this is the question. Okay, so you can solve them and tell me your answer in the comment box. Okay, even if it is wrong, no issues, you just give a try. Okay, yeah, if there is any mistake, I will help you while doing the question. Okay, no worries. The next one here is, second question here is 90 grams of glucose. What is the formula of glucose? Glucose C6H12 glucose, C6H12O6 is given. Then calculate number of moles of glucose. How many moles of glucose is given? Number of moles of glucose, and then next calculate number of moles of carbon atom, number of moles of carbons. Okay, that's it. Yeah, you just try these 2 questions and tell me your answer in the comment box. Okay, done. Next, let me show you few more questions here. Yeah, these are the 2 formulas you can use. Already we discussed. Number of moles means given mass of the substance by molar mass. Okay, for number of moles, the unit is itself as a mole only. Okay, for molar mass, units will be gram per mole. Okay, and for given mass, it will be gram get cancelled, so we are finally remaining with moles as a unit. Okay, now sometimes they will give you a number of particles, like they will mention something like this. So 3.011 into 10 power 23 oxygen atoms they will mention like this. Then calculate number of moles, or given amount of substance for this oxygen atom. So what you can do is, oxygen atoms they have mentioned now. So if I say number of moles, that is nothing but in 1 mole of any substance, we have 1 mole of any substance contain Avogadro number now. So divide this number with Avogadro number. So always divide the given number with Avogadro number. So what is Avogadro number? We have 6.022 into 10 power 23. Okay, divide the given number with this number 23. So how many moles we got? How many moles we got? It is something like a half mole we got, half mole we got right now. So half mole of oxygen atoms are given. Now half mole of oxygen atoms means how much weight it will be? See, the given weight is half mole, so N value will be half. Now multiply that with molar mass, multiply that with molar mass of oxygen. So oxygen atoms they are saying now, so 16 grams, so 16. So it gives you the amount of mass of oxygen atoms, So if I give you this many number of oxygen atoms, then what is its weight? Its weight will be 8 grams. How many grams it will be? 8 grams. If you measure the weight of this many oxygen atoms, మీరు ఇన్ని ఆక్సిజన్ యాటమ్స్ తీసుకొని దాన్ని మెజర్ చేశారనుకోండి, దాని వెయిట్ ఎంత వస్తుందంట? 8 grams వస్తుందంట. హౌ మెనీ గ్రామ్స్ ఇట్ విల్ బి? 8 grams. సో it is very useful not to express the amount of substance, or by giving the amount of substance how many atoms will be there in that substance, right now. So that's why mole concept is one of the most important topic of your complete chemistry. Okay, right. Next, here few questions are there. You can try all these questions. See, for the answers for all these questions were given in the previous session. It means day before yesterday's session you check. Okay, there I have discussed, when I am discussing about molecular weights or atomic weights, I have explained about this number of moles. I mean, these questions also we discussed there. Okay, you try all these questions are for you. Okay, you try them. See, just now we did number of moles in this many number of nitrogen atoms. So the given number divide with what? Divide that with molar, Avogadro number, so that it will give you the final answer as 2 mole. You just try it and tell me. Next, this question also you can do. See, given mass is given. Divide the given mass with its molar mass of that oxygen, you will get the answer. Right now? Yeah, next. So 9 grams of water. So this is also simple. The given mass divided with molar mass of water. What is the molar mass of water? H2O na formula. So H2O. So it will be 2 hydrogens, 2 into 1 plus oxygen atomic weight is 16. How many oxygen atoms are there? 1. So total sum is 18 gram per mole. So we got molar mass of water, number of like given weight is given. So number of moles. How can you do this? Number of moles is nothing but given weight by its molar mass. Molar mass is how much? 18. So this will be 1/2 mole. So you got it as 1/2 mole. 1/2 mole of water molecules we got. So half mole contains half into Avogadro number. Avogadro number means 6.022 into 10 power 23. So what they are asking us? Number of water molecules present. So divide this number. So 3.011 to 10 power 23 water molecules are present in the given 9 grams. Okay, like this you can solve this question also. If you are unable to solve any of that question, don't worry, you watch my day before yesterday's session, there I explain the same questions. Okay, right. Next let us move forward. Yeah, so there is something called ideal gases. What I am saying, ideal gases, and we have an equation called ideal gas equation. So you might have came across this thing, Boyle's law, Charles' law, Avogadro's law, all these things. So from all those laws we are going to get a final equation like PV equals to nRT. So the gases which are considered to be ideal follows this gas law. If the gas obeys this equation, this is called ideal gas equation, then we can consider that gas as an ideal gas. Okay, so about this we will discuss, like how we got this. Again I will explain in thermodynamics, states of matter, but now just remember, so this equation is called what? Ideal gas equation. What equation it is? Ideal gas equation. So now gases which obeys ideal gas equation are called ideal gases. Okay, right. So now why do we need to study these? Yeah, I will tell you. So we know 1 mole of any substance means its mass will be equals to the molar mass of that substance. What is it? Molar mass of a substance will be equals to 1 mole of that substance. Now 1 mole of any substance is found to, any substance means gaseous substance. 1 mole of any gaseous substance which is considered to be ideal occupies 22.4 liters of volume. How much volume they have? 22.4 liters of volume at STP conditions. Just remember it like this. Okay, what I am saying, 1 mole of any gas substance you can take that occupies how much volume? 22.4 liters. So how we got this? This is an experimental observation. So now let me tell you one question here. See, consider oxygen gas as an ideal gas here, O2 as an ideal gas. Okay, so now O2 gas is ideal means, let us say 2 moles of oxygen is given. Oxygen is given. So we know oxygen gas is an oxygen is a gas only, no? So consider it as ideal gas. Now present in this container, that is present in this container. So oxygen gas is present in this container. Now what is the volume of this container we can say, because oxygen gas occupies how much volume I am saying at STP condition. So at STP condition, I will tell you what do we mean by STP condition. So at this STP condition, O2 gas occupies 22.4 liter. So again I am saying this, 1 mole if you take 1 mole of any gas, like 1 mole of O2 gas if you take, it occupies 22.4 liters at STP condition only. At what condition? At STP condition. I will tell you what do we mean by STP, just write like that. Okay, so the given gas is how much? 2 mole, no? So 2 mole means 2 mole of O2 means, see from here to here it is double, no? So volume also should be doubled. So it will becomes 44.8 liters. How much? 44.8 liters at STP. So 2 mole of this oxygen gas occupies 44.8 liters at STP. ఇలా అర్థం చేసుకోవాలి. Okay, then ఇంకా simplify చేసి చెప్తాను, just hold on. Okay, so now what do we mean by STP? So this is called standard temperature and pressure. What I am saying, standard temperature and pressure is called this STP. STP means what? Standard. STP means what? Standard temperature, pressure. Okay, so what is the standard temperature here? You can say it is 0 degrees Celsius. What I am saying, it is 0 degrees Celsius or 273 Kelvin. 273 Kelvin, both of them are same. Okay, and pressure is considered to be 1 atm. Okay, so 1 atm you can consider, as of now you can consider like this. We have both STP and TP conditions. You just consider, as of now you consider the volume as 22.4 liters. Okay, so there is small difference, we will discuss in the mole concept again, when we start the 11th class topic. But now you remember 1 mole of any gas occupies how much volume? 22.4 liters at this condition. Okay, sir, why only at that condition? If I change the temperature, what happens? Yeah, even if you change pressure or temperature, the volume occupied by the gas also changes, because upon heating a gas, what happens? Expansion takes place. If it is expanding, the volume occupied also increases, right now. So that's why do not change anything like pressure or temperature. Fix the temperature and pressure as these conditions only. Then at this condition, that gas occupies 22.4 liters. Okay, not only this gas, take any gas which is considered to be ideal occupies 22.4 liters. Okay, right. Now let me tell you, 1 mole of methane gas at STP, how much volume it will occupies? So 1 mole I am saying, na? So just take it as 22.4 liter only, directly 22.4 liter. Okay, this is fixed. Okay, so instead of saying 1 mole, I can also write 1 mole of methane. Number of moles is nothing but weight of substance by molar mass. So how many moles I mentioned? 1 mole. So 1 mole into molar mass. So its molar mass is nothing but equals to given weight. So what is the molar mass of the substance? 16 grams. So instead of saying 1 mole of methane, I can also say it as a 16 grams. So 16 grams of methane at STP occupies how much volume? 22.4 liter. Now what I am giving is, I am giving you only 8 grams of methane, 8 grams of methane only I mentioned. So how much volume it will occupy? Tell me. See, if it is 16 grams, 22.4. So I have halved it, I just divided here by 2, 16 gram becoming 8 grams. So here also what happens, 24 liter, 22.4 liters becomes 11.2 liters. Okay, is this clear everyone? So now I am going to make one simple relation here. So number of moles is equals to volume of gas at STP, volume of gas at STP by 22.4 liters. Just take it like this. See, so what I am saying is, I have given a volume something like 5.6 liters. How much? 5.6 liters of O2 at STP. Calculate number of moles of O2, number of moles of O2 and weight of O2. See, in the question they have mentioned like this, 5.6 liters of O2 is given at STP, and they are asking us to calculate what is the number of moles of that O2 or what is the weight of that 5.6 liters of oxygen. So it is simple. First find number of moles. How can you do this number of moles? How many liters they have mentioned? Take it in the numerator, 5.6 liters. Okay, and in the denominator what is the value mentioned? 22.4 liter. Okay, so this will be 4 times 5.6 4s are, okay, 22.4. So you got how many moles? 1/4 moles of O2 we got, something like this we got. Okay, number of moles we got now. From that we can find weight also, because number of moles is weight by molar mass. Okay, from here number of moles are half, and what is the molar mass of O2? This is 32 gram per mole, no? So you can take 32 gram per mole. So this gives you what is the weight of the substance. Okay, so here you have mole get cancelled here. Okay, this mole get cancelled here, so this will be 8. So what is the weight of O2 we got? Weight of O2 will be 8 grams. Okay, like this you need to calculate. Okay guys, is this clear whatever we discussed? Yeah, see, today's class is one of the most important for your mole concept discussion. Okay, so once again go through the discussion whatever we did, and if you have any confusion please let me know. Okay, if you are unable to follow any of these things, please mention, I will discuss them in the upcoming session once again, but you must need to understand this whatever we discussing. Okay, right. Alright, let me explain few more things. Here you can see, try to solve this question, try to solve those two questions. Yeah, the first question here you are seeing, both of them I think so PYQs only. First question is definitely a PYQ question. So just look at this. PYQ means previous year question. Okay, previously asked question here you can remember. So tell me, how can you solve this question? 5.6 liters of a gas at STP weighs this much. What will be the possible gas out of the 4 things? Say 4 gases are given. So out of these 4 gases, which gas will be having 4.25 grams if we take the quantity as 5.6 liter at STP condition? So now what you need to do is, first find a number of moles. How many moles 5.6 liters means? Okay, it is simple, 5.6. What I told you, number of moles can be calculated from the given volume by volume given at STP by It's molar, it's like 1 mole of gas occupies how much? 22.4 liters. Okay, so 5.6 by 22.4. So this will be how much? Half mole, like 1 by 4 mole. So how many moles we got? 1 by 4 mole we got, 0.25 mole we got. So now they have given weight as 4.25. No? This is very simple. So now what you can take is number of moles is equals to given weight of substance by molar mass of that substance. Molar mass of that substance. So now what I am doing is, if I directly find molar mass, one of this gas will be having the same molar mass as we are going to get in the answer now. So molar mass is equals to given weight of substance by number of moles. What is the given weight? 4.25. And how many moles we got? It has 1 by 4. So 1 into 4. So this will be how many times? This will be 5 4s are 20, 0, 2, 8, 9, 10, 0, 1. Okay, 4 4s are 16, 1, 17. Okay, 2 decimals here. So how many grams we got? Molar mass is 17 gram per mole we got. So which of these gases having 17 grams? Tell me as a molar mass. So if you observe for ammonia, nitrogen will be 14 and hydrogens 3 are there, 3. So it is 17. So our answer will be definitely first option. If you want to verify the other options also, just check. Carbon is 12, mass is 12 and oxygen is 16. So how much is it? 8, 28 we got. Okay, it's not a correct one. So remove this. Next, go through this one. Oxygen we know it is 32, not this one. Okay, this one 2 into 12 plus 6. So how much it will be? 24 plus 6, 30. This is also not the correct option. So what is our suitable answer for the discussion? First option. Okay, I hope it is clear. If it is not clear, once again rewatch it. Just go back to 1 minute and watch it properly and solve it. Okay, yeah. So these models are important now. So the next one, what they are asking, maximum number of molecules present in. Maximum number of molecules present in. So what you need to do is, first of all, find number of moles. More the number of moles, then that gas will be having definitely more number of particles. So first number of moles you find from the given substances and that multiply with Avogadro number. Then whichever be the greater number, that will be your answer. Okay, you just try it and tell me your answer. See, here they have mentioned it as 5.4 liter of CO2. So 5.4 liter divided by molar, 22.4 liter. So half mole, 1 by 4 mole we are getting here. Like that, if you calculate for this one, so 15 grams of CO. So C means 12, oxygen means 16. So it will be 28. Okay, so 15 by 28. Like that, if you consider, this is around like 1 by 2 around, you can say. Okay, so this one also you take, given weight is 20 grams and what is the molar mass of N2O4. So N2O4 means what you need to do, so nitrogens 2 are there, each one is 14 plus oxygen 4 are there, each one is 16. So this is 64 plus 28. How much it will be? 12, 1. So 92. So like this, given weight divided by its molar mass. Like this, if you calculate, what we are going to find? Number of moles. More the number of moles, more the number of molecules. That's it. So greater the number of moles, that will be your answer. Okay, so you can do it for this one also. See, given weight is 4 grams. What is the molecular weight of hydrogen? It is 2 gram per mole only. So definitely our answer will be 4 by 2 means it is 2. So 2 mole we got. So 2 mole, so 2 into Avogadro number of particles we have. Everywhere the number of moles is less than 1. Right now, here it is 1 by 4, here it is something like 1 by 2, here it is something like 20 by 92 means definitely less than 1 by 5 also, like 1 by 4 also, definitely less than 1 by 4. Okay, it means what we are going to get here, it is 2 into Na means this is the biggest number we have, more number of moles here. So option 3 will be a perfect answer for the discussion. So ఇలా మీరు ప్రతి క్వశ్చన్ ని సాల్వ్ చేయొచ్చమ్మా. See this question from law of conservation of mass, you can easily answer once read the question. A hydrocarbon on combustion, so they are saying hydrocarbon, hydro means hydrogen, carbon means like we know, so this is a compound made up of carbon and hydrogen only. So just write it something like this, CXHYZ. On combustion means oxygen. Okay, so it means you treat that with oxygen, so gives you CO2 plus H2O. H2O. Now see what the data provided. Hydrocarbon weight is 3 grams and oxygen weight is 11.2 grams. So what is the total mass we got? 14.2 grams. What is the left hand side of the equation? Total mass is 14.2 grams. And this side they are saying it is producing 8.8 grams of CO2 and 5.4 grams of H2O. So this total mass is also 14.2 grams only. So total mass of reactants and total mass of products are equal. So this data providing, what you are providing, this data saying the total mass during the reaction will be conserved. The mass of a total mass of a reactant should be equal to total mass of products formed. Okay, this is what law of conservation of mass. So where do we have that option? Conservation of mass. That is first answer is your perfect. So if you are not aware of law of conservation of mass, you just watch my previous discussion, that is the third session, I think so, third session of this bridge course. You can watch it. Okay. Now look at this question, the above question. Element A having molecular weight 20 and element B having molecular weight or molar mass 30. Okay. These two combine to form a compound with molecular formula as A2B2. So what is the molecular formula we got? A2B2. Now for this molecular formula, for this particular formula, what is its molar mass they are asking? Very simple. How many A's are there? 2 are there. So 2 into what is the molar mass of each A? That is 20. Okay, plus how many B's are there? 2. Each molar mass of this B is 30. That's it. So simply add them, 40 plus 60. So this will be 100 grams. How many grams? 100 grams. That's it. Where do we have that option? 4. This is your answer for the discussion. How simple they are. So read the question, try to understand. Okay, don't sit simply in front of camera or in front of phone. Try to solve the questions along with me. Okay, so whatever the subject is going on in the discussion, just take your pen paper and you can also solve along with the teacher, or once after completing the session you try all those questions once again, because you are at the initial stage at the beginning now. So you need to be very careful while you are learning something new. So don't think, yeah, I understood, so no need of doing. Don't think like that. You must practice once on your own. So just give a try for each and every question that is discussing on the board or given as a homework. Okay, so that you can make yourself more clear and more confident about your preparation. Okay, right. Even if you have any modules or any previous books or anything, you just go through them and try to solve the questions related to these concepts. They are highly helpful. And you yourself feels, you gain so much of confidence that I can easily crack any exam now related to this subject. So that is a concept concept and confidence you required at the beginning stage to make you yourself accelerate your preparation. Okay, yeah. Next. So percentage composition I will discuss in the next sessions anyways. Yeah. Now I will show you one more important application of this mole concept. So this is called stoichiometry and stoichiometric calculations. I will tell you about this in the upcoming sessions, but now anyways we discussed about mole concept now, that's why I wanted to add here. See how mole concept is useful. H2 plus O2 gives rise to H2O. So during a reaction, this is the reaction we are doing to form water molecule. First of all, balance the equation. How many hydrogens are at the product's reactant side? 1 hydrogen molecule. 2, it means 2 hydrogen atoms. So this side also should be 2. In order to make that 2 is fine. How many oxygens are there at the product side? It is only 1. But reactant side, 2 oxygen atoms are there. So take it as half. So half into 2. It will be how much? 1 oxygen atom, like this. Okay, I hope it is clear. First step is to balance the given reaction. Okay, yeah. So after balancing, whatever the numbers you are seeing at each of the reactants in front of each of these reactant and products are called coefficients. What they are? Coefficients. Coefficients of H2, O2 and H2O. Okay, like that. So now what are the coefficients we are seeing? 1, half, 1. Like this we have. So what does this says? is 1 mole of hydrogen gas react with half mole of oxygen gas to produce 1 mole of water molecule. What it is saying? 1 mole of hydrogen gas reacting with half mole of oxygen gas to form 1 mole of water molecules. In the same sense, we can also give in terms of weight also, because we are measuring the things by weights only now. So what is the weight of hydrogen? Like number of moles is equals to given weight by its molar mass. So I want weight of the substance. Weight of the substance equals to number of moles into its molar mass. So what is the molar mass of hydrogen molecule? 2. So 2 into 1, because 1 mole now. So it means 2 into 1 is 2 grams of hydrogen reacts with half into, what is the molar mass of O2? 32. Okay, 16 grams of oxygen to form 1 mole of water molecule now. So 1 into how much molar mass it will be? 18. So 18 grams of H2O. So now if you observe carefully, how many grams of water molecule is formed? 18 grams. Here the reactant side also, how much mass we got? 2 grams here and 16 grams. So total it is 18 grams. See, total mass of the reaction is conserved. Law of conservation of mass is agreed in the equation. Like this, we can able to calculate even to get 18 grams of water, how many grams of hydrogen should be considered, how many grams of oxygen should be considered. Like that we can able to calculate. For example, here I am saying you a simple question. Instead of forming 18 grams of water, I just want only 9 grams of water. What I can take now? Tell me. I want only 9 grams of water. In order to form 9 grams of water, how much amount of hydrogen and how much amount of oxygen I should take? Minimum amount I am asking. So minimum amount will be, see, for every 2 grams, 16 grams is required. Therefore, we will get 18 grams. Okay. So in order to get 18 grams, how much I am saying here? 16 and here 2. In order to get this 9 grams, you just, what you did from here to here, you just halved it now. So here also you take half. So half of 16 is 8 grams of oxygen you take and 1 gram of hydrogen you take. So upon adding this 1 plus 8, 9 grams we are going to get as a water. Okay. So like this, even using mole concept, we can do amount of reactants required to form particular amount of product, or if I take particular amount of reactants, how much amount of product is formed. అంటే ఒక రియాక్షన్లో మనకి కావాల్సినంత ప్రోడక్ట్ ఫామ్ కావడానికి ఎంత రియాక్టెంట్ కావాలి, ఎంత స్టార్టింగ్ మెటీరియల్ని తీసుకోవాలి, ఇలాంటివన్నీ కూడా we can calculate using mole concept. I hope you got the importance of mole concept in the chemistry part. Okay, so thanks for watching. Stay connected with our NEET World channel. If you have any confusion, please let me know in the comment box. So you can also share this with your friends who are moving from 11th, class 10th to 11th or 11th to 12th, who are feeling like they are not having proper basics or they want to have a strong command over the basics. You can share these things to those students. Okay, so thanks for watching. Stay connected.